So I think you're expecting Oliver Tweedy, but he's tied up actually, so he couldn't make it. So I've had to step in ridiculously last minute to come and talk to you today. So go easy. So we're here to talk to you. As I say, I'm Stephen, a project manager. I've been working with Sky for about 18 months. And the use case we're here to talk to you today about is a large-scale streaming use case using Apache Beam. So we'll get into the detail on what that is. So I think most of you probably know or have heard of Sky. This deck was taken from a conference where it's not necessarily known, but Sky are a major media provider in the UK and Europe, 22 million subscribers in total across UK, Italy, Germany, and Austria, and due to expand to other countries as well, I believe France as well. And they're a quad play provider, so it's TV, broadband, phone, and also mobile in recent years as well. And in 2017, they selected Google Cloud for their data and analytics capabilities. Obviously, it's a massive organization, so many technologies are in use, but there was a strategic decision to align with Google. So the specific use case we're here to talk to you today about is a product Sky have called Sky Q, which is their premium flagship product. Is probably the best way to think of it. So it's satellite on demand. They partner with third parties such as BBC, ITV, Channel 4, and there's soon to be released a partnership with Netflix as well to promote and integrate content on the Sky Q platform alongside other Sky content. I guess the USP to talk about is that the box themselves integrate in the home, so you can have a main Sky Q box in your main living room typically. And then you'll have mini boxes throughout the home as well, and all of the boxes interact with each other on a mesh network. You can pause on one device, resume on another. There's some clever interconnectivity. And the use case which we were involved in was to capture diagnostic events, so events that occur on the box that get generated every time an event happens, and it was to capture that data at scale on a reliable infrastructure. And the key kind of use cases we were looking to fulfill were around journeys, features, and also the content that's being consumed. Looking at what's most popular, what works well for customers, what's problematic and needs improving. So that's the kind of context around the use case that we both worked on. So when Sky Q originally launched, there was already an existing warehousing solution that was put in place to capture this data. But as you can imagine, particularly for something like television, the demand and the number of events being generated it's not linear. It spikes both throughout the day and it spikes throughout the week and throughout the year. So predicting what volume of data is going to come in is pretty hard. In fact, it's pretty impossible. So the existing solution was hosted on a Cloudera Hadoop cluster, and events were streamed in. It generally functioned okay, but there was a lot of operations time required to keep that infrastructure stable. So if there was a spike in events, spikes would typically occur on one solution, and the same effect would happen on other solutions running on the same infrastructure. So this was a problem that was kind of constantly being faced. The solution was functional. It provided value to our business stakeholders, but similarly, if there was ever a data gap which occurred through failures or whatnot, then consumers tended to lose faith in the data, and it was a problem that needed solving. So it was ideal for a GCP use case, effectively. So back in mid-2017, I was asked to lead on this project by Oliver, who unfortunately couldn't be here today, but he was the main project sponsor looking to kick off this initiative. So the team was assembled with me leading it, and then a partnership with Datatonic, which is why Matthias is here, and some of the other guys who are still working on the team are in the back of the room. So we established a team, as I say, with myself, Datatonic, and then a team from Sky who looked after the existing solution. And the idea was to POC, could the infrastructure handle the use case that we were looking to fulfill? And then once we proved the capability, it was to build it out into a kind of production-grade, enterprise-ready state. So I think, the main thing to call out, which for someone who's worked on projects before, having a blank canvas like this was just, it's pretty rare that you get to pick up a complete blank slate, start a new project using new infrastructure. So it's been really good fun to work on. The infrastructure that we went with, as you can see from there, was, I guess, what you'd probably think of as the kind of canonical way of building a solution on GCP. So events were pushed into a pub subtopic. We then had a data flow pipeline, which Matthias will talk about in a bit more detail. And then the events are streamed out into BigQuery, where they're used for either ad hoc analytics processing or a kind of repeatable set of reports, which we actually run in Tableau. Beam itself, which I know is I'm probably talking too much about Google technologies, but Beam, which is the kind of core of this conference, the two things to call out are that when an event occurs on a box versus when we receive it, there can be quite a big lag in that step. And also, we're not guaranteed to receive events, so things like a box being turned on, that's quite an important piece of information, but if we don't receive it, then we need to come up with some sort of generic rules that cater for that data being missed. And also, of course, data being received out of order. So we might receive someone clicking onto an asset or watching a program after they've turned, or rather before they've turned on the box, and we need to be able to handle these kinds of discrepancies. The one other thing to point out as well is around the fact that we've modeled this in Beam such that the solution is portable if we ever did need to switch off of Google. One of the big factors which Matt, who sat over there actually, he's always drummed into us that we need to try and remain technology agnostic because things can change so quickly. So it was something that was always at the back of our minds, and we've stuck to. So I guess continuation from what I was just saying, actually, the events never stop. They run 24 hours a day, 7 days a week, 365. So we're always receiving TV events as soon as they occur, which means we need a system that can handle that. And similarly, as I say, there's the huge lag potentially between when an event occurs versus when we receive it. And to kind of mitigate all of that, I mean, Matthias can go into a bit more detail on this, but to mitigate both missing events and the delay, we had to adopt some, what I would say, are generic rules to processing data. So the one rule we apply is when we pick up a new session, so if you imagine that no session is active at present, and a session is a user watching something. So if there's no session running for that box, we will start a session, and then that session will continue either until there's a gap of 4 hours of when we haven't received any more messages, or 24 hours elapsed since the first message. And these aren't hard and fast rules that are always accurate, but we found through experience in the previous solutions we've run, this was kind of the best middle ground for what we were looking to deliver. This chart's actually a bit out of date now. It's from a previous slide. We actually hit a new PB today of 520 million messages. So this has scaled up pretty linearly over the past kind of 6 months in terms of the number of messages we've received each day. You can see that the number of messages varies pretty significantly. I mean, not hugely, but it does. There are notable trends, obviously, around weekends. And if you looked on a specific day, you'd see the evening spike massively in the UK. But yeah, this is just to show that we've tracked a nice linear increase in the number of messages as SkyQ becomes a more popular product and rolls out. And I'm going to hand over to Matthias in a sec, but this is just to kind of kick off, I guess, the architecture and how we came upon the solution and just some learnings. One thing I would say is that for anyone who is thinking of starting a new solution in Beam, or you've already built one, I'm sure you could appreciate that how you design a solution up front, you might have a view of how you think it would function and fit with the use case and how people want to access and use the data, but chances are in 6 months down the line, you'll look and you'd wish you'd designed it completely different. And once you have a solution that's functioning and active in production, it's harder to refactor and adjust it going forwards. So the key things we would call out would be to really understand who your customer is, what the questions are that they're looking to answer, how often they want to answer them, how much latency are they happy to accept. And that goes both ways. It's not always, someone might generally say, we need this data real time. Everyone wants real time, but when you get to the crux of what are they actually planning to do with the data and how much do they need real time? Because it's not only, there's the processing costs of the infrastructure and whatnot, but it's also the development cost and the development time of getting to that point. And There are a lot of use cases in Sky where it does require this level, but similarly there's people who, if they get the answer each morning, that's generally okay for them. So it's about understanding who your customer is and what they're trying to do with the data that you're going to provide them. So I think I'll hand over to you now, if that's okay.
Cool. Yeah. Thanks, Stephen, for introducing the use case. And hi, everyone. I'm Matthias. I was one of the engineers working on the solution for SkyQ Analytics at Datatonic at the time. And I'm going to walk you through the technical aspects and the architecture of the solution we built. So first of all, we started with identifying the two data sources. First of all, like Stephen mentioned, there were the Sky boxes sitting in the people's homes, generating messages whenever they happened. So these were JSON messages. And the first consideration we actually made when we were starting to design the solution is that we needed a communication channel between the people that wrote the software that generate these messages, as well as to us who were going to process these messages. Because they decide on some kind of schema they're going to send to you, but we are the ones that are actually going to consume this data. And if we fail to actually have a protocol on how we're going to process the data, as well as maybe roll out a new schema, we might fail to capture some of the relevant data we want to analyze at a later point. So the second data source we have are the reference feeds. So this was generally more information that Sky already had. For example, data on the programs being broadcast on TV right now. That was going to be relevant in some of the downstream analytics to actually have meaningful analysis of the data we were taking out of the boxes. So that gives us the raw data, but obviously we want to process this data. And this brings us to how we're going to ingest it into our processing systems. First of all, we have the data in motion, which is the data that comes off the set of boxes and gets produced in real time. And this is basically ingested into a message queue. In our case, we use Google Cloud PubSub, but it might have well as been something like Apache Kafka. Next to that, we have the reference feeds, which are the data sets that sat on Sky on-prem systems, and those got staged to our data warehouse. For us, it was Google Cloud BigQuery. Next up, obviously, we wanted to process this data, and this is where Beam comes in. So our first processing pipeline was reading the messages from Cloud PubSub in real time. So it was a streaming pipeline. The things we did in this pipeline was parsing the data. So we enforced the schema and we logged faulty messages to a dead letter queue. Other things we did was, for example, archiving to a cold storage. We were filtering some data. And we also did the sessionization Stephen talked about earlier. And I will dig into a bit more later on. Actually, then the result of this pipeline got output to BigQuery, where BigQuery did the heavy lifting of joining the reference feeds with the data coming off the set of boxes. So this brings us to another pipeline that actually consumed this data out of BigQuery. And this was a batch pipeline, which we call the enriching pipeline. And we actually applied some more complex algorithms that analyzed these sessions and the user's journeys in the pipeline. So for example, we would look at what are the most products people use in general, stuff like that. This is also where, for us, we found out about the easiness of writing this processing logic in an imperative language like Java or Python, because it ended up being a more maintainable and modular code base compared to having some scripts in a declarative language like SQL. So, because obviously this is a Beam summit, we're going to zoom in on the Beam pipelines a little bit more. And I'm going to do this by asking the 4 questions that people usually ask when developing a Beam pipeline. So first of all, we have the question, what are we actually computing? And I'm going to split this up in the processing pipeline and the enriching pipeline. In the processing pipeline, it was mostly element-wise transformations, so like the parsing, the filtering, etc. happening, so only operations on one element and not a group of elements. While in the enriching pipeline, we were actually looking at the set of events that was attached to one key, so one user or one set-top box, and we're going to do some aggregations on that data, for example, looking at the time they spend in the sub-level menu or the number of clicks they do on an average journey. Second question we ask when developing a Beam pipeline is where in event time do we calculate? Because, like Steven mentioned, we were coping with an unbounded stream of data, you had to batch up the different sets of data before you can actually do an aggregation on this. And that's what we did with the sessionization. So basically, we look at the burst of user activity of some clicks happening. And then after a certain time of inactivity, the session stops and we move on to a new session. When in processing time, do we actually calculate the results? For this, we have different triggers with different conditions. So the first trigger would be the early trigger. So like Steven mentioned, after 24 hours, you want to cut off the session, because imagine if you have someone pressing the button every 5 minutes, you would theoretically end up with an infinite session, and you don't have infinite memory. So that would be a problem. So after 24 hours, we emit an early trigger, and we start over again. Second of all, we have obviously the on-time pain, which is based on us being confident, or well, PubSub and the watermark being confident enough that all the data that is relevant for that session has arrived in the pipeline, and we can emit a result. And the last trigger is the late trigger. So imagine if we're confident but not right. There are some late events that arrive in the pipeline. We can still handle these with the late trigger, and we can, for example, consolidate the session at the end of the month. The last question then is how do the refinements relate? So in this case, we were using discarding pain. So whenever the result is emit, we get rid of the buffer and we start a new session. So moving on to the actual consummation side of the data. Like Steven mentioned, we had different groups of users. And the first one we identified are what we call the advanced data users. Those were people in general writing their own queries, taking care of their own logic, and taking care of their own joins. And obviously, they benefit from, they were consuming from the processing pipeline, so they benefit from the data arriving in real time. But they also needed to take care of their own logic, so they spent some more time writing their own queries. The second group of users were what we call the normal data users. So those were people consuming data from the enriching pipeline. They could benefit from some of the pre-calculated measures we did in that pipeline, as well as doing their own queries on top of the data. So they still have the freedom, but they also don't need to take care of their joins and their logic. And then as a last group of users, we have the dashboard users who are consuming Tableau automated reports. And basically, they get a dashboard ready every morning to look at their use case they're interested in. For example, what is the trends on product usage? So this brings us to the overall architecture, basically, where we went from the raw data, the ingestion part, then to the processing part with a streaming pipeline, which gets ingested in BigQuery, where the joins happen, and an enriching pipeline where some more complex logic happens. Again, we go to BigQuery, and then we have our consumers either writing queries or consuming dashboards. Obviously, this is not everything that was happening, so I want to highlight two extra components that are quite relevant. So first of all, we have monitoring set up, obviously, for this whole system. Because imagine you have data going in, you also want the same amount of data going out. If this is not the case, like we had once when the schema changed, we were losing some messages. And then this is something you can notice then if your volume starts to drop while it's not expected. In this case, we use a Stackdriver for the monitoring. And the second component I want to highlight is the scheduling system, for which we used Apache Airflow. And Airflow was basically taking care of the batch pipeline happening at the right time, as well as the joins happening at the right time. And with that, I want to hand it back to Steven to wrap up our talk.
Yeah, so I've worked on projects before with other technology, and I was absolutely astounded, to be honest. I think it was a combination of the team and the technology, but it was really quick to deliver relative to other kind of what you'd think of as legacy ETL. So we actually, I mean, from when we kind of really hit the ground running in starting development to the first deliverable functioning pipeline, it was around 5 weeks, which I know there's always these claims that get thrown around with software, but it really was surprisingly quick. Partnership was a really good success. So we had a small team. I mean, it was max 6, 7 people, but we came together, closely co-located, working together, and it worked really, really well. And this is kind of unlocking for our customers who've sponsored this project. It's unlocking a whole host of new things that they can do. So there has always been the concept of A/B testing, but we've enabled much more granular versions of that. So testing out new features on small sets of customers rather than having to release new features to the entire base. So it's really already we're seeing great benefits. This slide just summarizes the kind of before and after situation. So as we say, you had an on-premise Hadoop fixed size cluster where you're competing with other solutions that are running on the same infrastructure. We've moved to a situation where we have our own dedicated set of infrastructure effectively, which we can increase or decrease as required. Literally just last week, we increased the max number of workers on the data flow pipeline from 15 to 20 to cater for demand, and it's a simple job. Back in the day, that would mean you'd have to go and talk to a vendor, order new hardware, get it installed. It's just a nightmare to arrange. But with this situation, we can just increase and scale our workload much easier. The costs as well, that's always a factor. So our sponsors are keen on this, that you don't have the big upfront CapEx cost of buying a cluster. Instead, you pay for what you use. If our workers scale up or scale down, we just pay for what we use, which is really attractive to people who are footing the bill. I guess the final thing as well I'll just call out is the operation side of things. As I say before, when we were using Cloudera and Hadoop, we had someone who pretty much spent 2 days a week managing yarn and adjusting what resources were allocated to which jobs and things. All of that has pretty much gone away. As I say, you have your own pipeline. No one else can touch it. The infrastructure is yours. Once it's done, it's ephemeral. Never liked that word. It just disappears. So it essentially means pretty much no operations from a platform side of things. And this is a quote from one of our other sponsors in the business. So we have Oliver, who kind of runs the GCP side of things within the data and reporting side of the business. But within the business, so we have a colleague called Dan Cronell, who's I guess he's head of data, but within the product side of things. And he's fairly technically minded as well, which has been a real asset. And he's really a big sponsor of the benefits that we've seen from delivering this solution. And as he says, it has the power to change the way we develop our products and has made us proud of what we've built together. So having a sponsor who understands what you're trying to achieve, can be pragmatic, can be practical. They don't want the world on a stick tomorrow. They understand this stuff takes time, but they're happy to accept trade-offs as well. So, if you want this, we can do this quick, the kind of Pareto analysis. You can have 80% of the value for 20% of the time. He's been a really pragmatic sponsor of ours, which has been good to have. And that's it from our talk. We're happy to take any questions anyone has. Cool. Oh, one question.
Yeah, I was wondering what tools were the various users using to interact with the data, like from the advanced users to the data users to the dashboard users?
Yeah, I mean the top 2 categories, I guess, both were BigQuery primarily. So we have different abstractions of the data. So you have the Tableau layer, which, as you know, is the kind of visual, simple front end that anyone can click on within a few seconds. They know probably what they're looking to find out. Then there's the reporting tables which sit behind those, which people might look into for a bit more specifics. And then the top advanced layer, we literally have, every of those 500 million events that get generated each day, we have a table which stores all of them. So, it racks up to billions each week. And the advanced people typically will go into there and they'll either be looking to answer a specific question or they'll be thinking about what else can we do, what questions can we answer that we haven't perhaps looked at yet. Although there's not too many, new things that crop up which haven't been considered. But I guess that's the best way of separating the 3 out.
Did you use Python or Java for your pipeline?
Good question. It was Java, but Matthias.
It was Java, yeah. Fully. Yes, because at the time, Python's streaming was not available yet. That was one of the considerations. And I guess part of the team was also trained on Java. So I think it really depends on your own company, what the people are trained in. And then performance is probably maybe another thing you want to look at.
Yeah, that's an interesting one because, with the whole hindsight thing, if we were starting the project now, we probably would have perhaps looked at using Python, particularly with the way the skill set in the industry as a whole is going, that Python is becoming just ever more popular. So, yeah.
Can you talk a little bit about the data path from the SkyQ boxes themselves into the Google platform? I'm just interested to know whether that uses a kind of internet path or whether that is a direct connection from Sky's network into Google platform.
Yeah, I had a feeling this might get asked, but I don't know enough about it to be able to articulate it that well. There is, as Matthias said, we have a good relationship with that part of Sky, but their ecosystem, I don't know the details of how. Basically, we provided them with a PubSub publisher set of credentials, and there is talk at the moment of whether we integrate. So Google have another product called IoT Core. We're experimenting with whether that may work as a kind of direct way of interacting between the box and PubSub, which would reduce latency even more. But I couldn't do justice to that question. I know the man who could if he was here, but he's not.
I actually have one more question. So what's the future at Sky then? Have you got any more data streaming projects that you'd like to use based on this kind of approach?
Good question. Yeah. Again, probably not for me.
Yes, is the short answer.
Yeah. So Matt Frank is one of the head of platform architecture at Sky. There's lots more. We've seen the potential. So it started out as a proving ground, and talking frankly, we didn't expect it to have the success that it did. And it went from being a POC where we could prove the value and get some insight, but it's continued to run as a stable, reliable source of data. So it's got quite a lot of attention, and there's talk of experimenting. So SkyQ is obviously one product that Sky has. I think there's 3.5 million boxes in total. We're looking to roll out in January, February next year to Germany and Italy. So at the moment we only capture UK and ROI. So we're looking to roll out to Germany and Italy, which we're starting development on at the moment. There's the Sky Plus ecosystem, even though it's not. I don't think it's actually sold as a product. If you wanted to sign up for Sky today, you couldn't sign up for Sky Plus, but I think there's still around 8 million boxes in existence. So there's potentially different things that we could do. And in total, I think off SkyQ there's about 8 different feeds which we could capture in a similar sort of ecosystem. But as you can imagine, they're not new, so there's already legacy technologies that, not legacy in a bad way, but as in existing technologies that are in use which serve those purposes. So I don't think anything's off the table, as it were. It's a case of cost benefit and what's worth doing.
So did you do a back of the envelope calculation before you did the implementation, and did you compare the costs to what it was actually in the end? But in developing on the cloud, you usually have higher costs, of course. But what I would be interested in is if you compare the solution before on premise, cost-wise, with the solution afterwards, is it like 20% plus, 20% minus, or equal, or what is your feeling about that?
Good question. No, we haven't actually done the comparison calculation. We know roughly like a number per day of the processing costs. But no, to tell you the truth, no, we haven't been asked to do the calculate. I guess it would be hard to attribute accurately what the previous costs were of using Cloudera, because it was a one-off CapEx investment. I guess you could quantify the operations time alone is valuable. But yeah, again, I was fairly surprised at how good value using GCP infrastructure was.
Hey, I'm loud. So I noticed in your architecture that you were joining reference data and you were doing that join in BigQuery. I was wondering if you ever contemplated doing that join in Beam, and if so, if you learned anything from that consideration.
Yeah, I got asked that exact question on another call like this last week, where they said, why did you use BigQuery, not Dataflow for that point? And there isn't really any sort of, it's a design decision that we made at the time. It's perhaps something that we'll refactor in the future, because it does make sense. You know, why have separate mechanisms of doing the same thing? So, yeah.
Yeah, so someone just asked me in the audience was, what was the team size and make composition for the delivery? And I'm going to do a compound question, Stephen, so apologies. Is there anything that both of you, with hindsight, would do differently, having been through this?
Bloody hell. Yeah, I mean, so the team size when we started was, so we had Andy, who's also at the back of the room, Matthias, a guy called Chris, a tester called Demetrios, and then architecture from a general oversight. So I think, and we had Stavros, so 7 people total, including analysis, test, architecture, and then the kind of core development team, which was a good amount, I think. If we're scaling the team, which, as you can imagine, always introduces more challenges. The more people there are, you have to be more rigorous over communication channels and things like that. So, in terms of what I'd do differently, I don't know.
I think it was actually good to have such a small team, because you were able to move very fast and you're trying to prove something before you actually scale it out to the full company. And with a small team like we did, we just could work together. We're basically on one island. We could, hey Stephen, hey Andy, can you do this or that, or can I ask you this or that? And that enables you to move really fast, which I think is part of the success of the project as well.
Yeah, and you'll have noticed from the argument Matthias mentioned that the second half of the pipeline is running in batch mode. When we first started, we'd planned for the whole thing to be streaming. But due to the way that the data arrives, it meant it wasn't necessarily practical. So I guess testing out the solution at the start on a bigger scale would probably have been helpful. But we've been able to adjust, so it hasn't kind of affected us detrimentally.
Hi, during your presentation you said something about trying to be cloud agnostic. At what level did you accomplish this? For example, if someone would say tomorrow you have to change to another cloud service, would you be able? Or
it's probably one for you, right?
Well, it's a good question, because obviously Beam is very portable, I think. We could move to Flink or to any other runner if you want. But there's obviously in the architecture, as you saw, we were relying on some of the other Google products like PubSub and BigQuery. So there's other options out there. Like I mentioned, I think Cloud PubSub could be replaced by Kafka. I think there are solutions for BigQuery, maybe Hive or something would be an option. I'm not sure if it would be super fast to move. I'm not saying that. But I'm confident we could pull it off if it was necessary.
Yeah, it was more a consideration. Don't try not to get too tied into one vendor, as it's just something to have in the back of your mind. Just when you're making design decisions, if there was a trade-off, go that way, essentially.